Department of Mathematics from St. Anne's Arts and Science College. Today we are come to the end of the unit 5, that is differential calculus, maxima and minima. So it is an important section. They will be asking in 2 marks as well as the 5 marks as well as the 10 marks also. Definitely you can expect the 10 mark question from this section. So maxima and minima of the function of two variables we are going to see. So continuous function in the xy plane take a maximum and minimum values, also called the extreme values. Basically, the extreme values are called as the maximum and minima values. Here, the saddle point we are defining the saddle point which is neither a maximum nor a minimum. And then for maximum and minima, we must have that formula, that is dou squared f by dou x squared into dou squared y by dou y squared minus dou squared f by dou x dou y by the whole square greater than 0. Or this can be written as fxx fyy minus fxy the whole square greater than 0. This is an important thing. This is you have to highlight the formula in all the questions whichever you are writing. So this only we are going to prove. For this we have some conditions. So find the first stationary points where f of x fx fy equal to 0. Let it be a comma b. Next we are going to calculate fxx fyy and fxy, and we are having some thing that fx is less than 0 and fxy is next fx6 is less than 0 and fx6 fyy minus fxy the whole square is greater than 0 at a comma b equal to maximum. Now this minimum means it's greater than 0 at a equal to b, which is less than 0 means it's a saddle point. So if it is equal to 0 means test is inconclusive. So the notations can also be used for fx. This r we can use for r, s, t also. So please keep the notations in the mind. Let us see the first problem. Find the extreme points of f of x comma y. So 4xy minus x power 4 minus y power 4. We are going to see the extreme point. First of all, we have to find the saddle points. So saddle point we should find. For that, the stationary points are fx is equal to 0 and fy equal to 0. So fx means that is 4y minus 4x cube. That is first differentiating with respect to x, that is fx. So 4y minus 4x cube will come, which is equal to 0. You have to apply. From this we can find the value of y, because 4y 4 get cancelled, so y equal to x power 3. Take this as the first equation. Next one, fy. Fy is 4x minus 4y cube. We are differentiating with respect to y. So I get x is equal to y cube. So second equation. Now substitute first and second equation. Second in first equation. So y equal to, in the place of x you have to write, so y cube. Y cube the whole power is y power 9. So y minus y power 9 can be written as equal to 0. Take the y outside. So 1 minus y power 8 equal to 0. Therefore y equal to 0 and y equal to plus or minus 1 will come. So further substituting the value of y in 1, we will get x is equal to 0 and x is equal to plus or minus 1. Okay, if you are substituting the value of x is y equal to value of y 0 and y equal to 1, what will happen? We will get the x values, that is 0 and plus or minus 1. Therefore the stationary points are xy, xy values, that is 0, 0, 0, 1, 1 and minus 1, 1. Now we are going to find the extreme thing, that is what they have asked, extreme points. So first we are finding the stationary points. Now fxx means, once again we are differentiating the fx value. Fx value is actually 4x cube. So fxx means 4 3 is 12, 12x squared will come. Okay, so 12x squared minus 12x squared, and fyy means minus 12y squared, and fxy is 4. Okay, now we have to substitute in the formula fxx fyy minus fx the whole squared. Now we have to apply, and we have to see that whether it is greater than, less than 0 or less than 0 or equal to 0. We have to find. So you get the answer like this. Now you have to draw the table like this. Point fxx fxy fyy and this term, then nature. First point 0, 0. What will happen? So if you are applying 0, 0 in f of x value, so you'll get 0. In f of xy 4, f of yy 0. So here in this place you have to apply, so minus 16 will come, which is less than 0, so it is a saddle point. Likewise 1, 1 we are applying, so we'll get 128, this is greater than 0, so it's a maxima. Again minus 1 we are applying in all those values, we are getting here as 128, which is greater than 0, so this is also maxima. So two cases we are getting the maxima. So maximum at f of 1, 1 we have to write it. The given question, you have to write, you have to substitute the value xy equal to 1, 1, you will get 2. Then maximum at minus 1, 1 you have to substitute in the given question, so you will get 2. This is the answer. Next, examine the maxima and minima. Previous problem we have seen the extreme points. Now we are getting the maxima and minima. So let us take a given function is given us like this. Now as usual we have to find fxx. So then fy, then everything you have to find, and then here find the value of x value as well as the y value also, like the previous problem. Now this value fxx minus fy minus fxy the whole square equal to, you have to write and then draw the table. So again the same only. So we have the points 0 0 minus 2 comma 0 0 comma 2 minus 2 comma 2. So substitute all those things, and here which is less than 0, so saddle point, greater than 0 maximum. This is 36 is greater than 0, here minimum, because see here both here the fx value and see here all those things is, this is greater than 0 and this is also greater than 0. Both the things we are having, then it is a minimum value. So already I have given in the conditions there, I have given that thing minimum where we are getting the minimum, and this is again less than 0, so it is a saddle point. So maximum at where the place minus 2 comma 0 only. So here, and minimum at which place 0 comma 2 only. So substitute and then get the answer. Okay. So again one more problem I have given for extra, so for learning well. So then the same thing only we are seeing, and then one more again extra 2 problems I have given for your reference. So go through it. Even though if you have any doubts you can approach me. So unit 5 ends here. Next we can move on to the unit 4. That is the only unit which you can complete it. So thanks so much for watching.